First GDB tutorial. In this tutorial, we're going to go and access the GDB tutorial from the course. First thing you need to do is download the tutorial file. Once that is downloaded, you need to go and visit the Jupyter Hub environment. We then need to copy the GDB file to that environment. You do that by dropping it into the file box on the left-hand side. Following that, you need to open the terminal window and you need to issue the following command. Make this a little larger. tar zxvf gdb tutorial.tar.gz. You should be able to use a tab to autocomplete the file name. That will create a directory called GDB tutorial. Let's navigate to that in the file browser. There's 3 tutorial files structured as markdown text. You'll be able to read those in just a moment. There's a GDB tutorial.c file that is the file that we're going to debug. We'll go through this really briefly. There's another file, GDB init. This is used in the third part of the tutorial. There's a make file which can be used to compile the GDB tutorial.c file. The program that we're going to debug has 3 functions in it that we declare: function 1, function sub, and function 2. I've written the code for the functions down below. We're going to be entering function main that calls function 1 and function 2. Function 1 allocates some variables, performs some math or assignments, and then calls function sub to do a subtraction operation and then prints out a result. Function sub just subtracts A from B, prints out a result, and returns. We don't really care what the program does, but we just need something that we can wind up stepping through a program. For function 2, what we're going to be mainly doing is looking at how, this is in the second part of the tutorial, how to be able to examine data. So in this case, we need to have some data to examine. So we have an integer array that is empty, an integer array that has some values in it. We also have an initialized string pointer and an uninitialized string pointer. And then we have a buffer that we're going to use for some functions. We also declare a C struct so that we can have a linked list or some dynamically allocated data structure to show how to follow pointers. Function 2 basically calls some additional functions to manipulate the data structures that we have. And at this point here, it's going to, at this point here, where it's using the uninitialized string pointer, it's going to probably have a segmentation fault. So an error in the program. It then goes through, does a for loop to initialize some data, and then prints out the data that we've just put into the data structure. You might want to take a look through the code. We don't really need to understand what it's trying to do in a whole lot of detail. So, and in fact, we're not going to look at that code during the execution because it'll appear in the tutorial windows. So now we're going to go into the GDB tutorial directory. Here we can type make, and that will then compile the program GDB tutorial. So we now have an executable file called GDB tutorial, and it's been properly compiled by the make file that was provided. At this point, what we're going to do is open up the first tutorial window. So this is a markdown text, and it should show us the steps of the tutorial that we're going to go through. And what we're going to do is we're going to collapse this file browser here, and we're going to open this with a markdown preview so it's a little bit more readable. We're not going to be editing the markdown text, we're just going to be looking at it. So we're going to collapse this file window here, and we're going to then split the tutorial text so that we have the tutorial text on the side and we have our GDB window on the left side here. Actually, I'm going to swap those two around. Um, it makes my monitor a little bit easier to do. Okay, so let's just walk through the steps of the tutorial. So the first thing that we need to do is we need to compile our program. We've already done that by executing the make program. And now we're going to execute the GDB command. So we're going to say GDB and then GDB tutorial. That's our program name. And we see all of the warranty information that's described over here in the tutorial. You can basically ignore it. More or less what it says is that you can get the source code for this program if you want to, the GDB program. GDB uses auto-completion. So there are different things that if we type help here, we can see that there's a set of help available to us. And if we want help on a specific item, so for example, if we want to say help break and we press tab, it'll autocomplete and show us what the possible completions are. So we can either get help on break range, or break points. In this help browser, which is a little bit more readable if the font's smaller, there's a lot of detail and it's hard really to read it effectively online. I would recommend that you search out the help, the GDB manual pages online. We'll provide a link for that. From here you can just exit by hitting Q, and we're back in GDB. So now what we're going to do is we're going to run our program. And what this is we just type the command run, and it then starts our program, presents some of the output of the program, and then we get a segmentation violation, a program fault, exactly at the point that we thought we would, which was computing the length of an uninitialized string. This program has an error at that point because the string pointer is equal to null. We'll eventually show how to find that using the debugger itself. The first thing we want to be able to do is walk through or step through the program. So we need to then set breakpoints. A breakpoint is basically a place in the program that we want to stop execution. We can have a number of different ways of identifying breakpoints. We can either identify breakpoints by a function name, or a file location, or a program counter address. In this case, we're going to set a breakpoint for function main, and we're going to then run execution and start it again. So now our program is running again, and now we're at the first line of the main program. So what we're going to do now is show you how you can use something called the text user interface. This is possibly useful. We'll leave it enabled during this tutorial. So we're going to do text user interface, TUI, enable. And this shows us a version of the file with then our GDB prompt below that. So this helps us understand where we are in the program execution. If we want to disable this, we can do TUI disable, and we go back to where we were, and we can also enable it again. If this display gets corrupted because output or other things make it look a little funky, if you press the Control L command or key, so in other words, hold down Control and press L, it will refresh that display. So we'll see that it'll get jumbled up when we print out some output. And then Control L will just make it display again. The B plus is where we have a breakpoint, and it also indicates with the arrow, it indicates where execution currently is. So what we're going to do now is continue execution from the point that we are, which is basically we're right before function 1. There are 4 commands we could do at this point that we will go through in different stages. If we just pressed or typed in cont or continue, we would continue execution as if we hadn't stopped at all. So we'll continue to the next breakpoint or until the program exits. If we typed finish, we would finish execution of function main. That means we would call function 1, then function 2, and then just as we're about to exit function main, we will get control back at the command prompt. we can also do next and step to execute one line of code. So if we do next, we're going to execute or step to the next line in our C program. So we're just about to call function 1. If we call next again, or if we type next again at this point, we will execute function 1, but we will not go through the individual steps that occur in function 1. We will go to the next line, which involves calling function 2. For now, what we're going to do is we're going to use step, which will step us into function 1. So in other words, we're going to go and start executing function 1. So this steps into a function as opposed to stepping or going over a function. So now we're in function 1. Again, we can step. We can hit just S to do the next step command. And in this case, we're about to execute the command z equals function underscore sub of x and y. We don't want to go into that function, so instead we just want to go to the next line. So as if that function had been, or actually call that function, but then just go to the next line. So we're going to do next. We can also just use n to do that. So now we've had some output printed. So here is the output that was printed by the program from function sub. And as I said, our text user interface display above is a little bit corrupted now. I'm going to hit Control L and it repaints it. So now we can go do finish. This will continue execution till we're about to, or until we leave that function. So now we've exited function 1 and we're back in procedure main. And again, I can press Control L to repaint the display. So now let's use the continue. So if we do continue, and I just use tab to complete that, we're going to see that execution continues and we have an error in our program. Also, our text user interface, because of the output that came out, was all garbled. The text user interface thing is sometimes useful. I'm not going to use it after this little part of the tutorial here, because I find that it gets in the way of understanding or seeing the commands that are there. But that's where we have the error in our program, and now we want to continue debugging. So in this case, we don't want to single step through our entire program all over again, but what we do want to do is we want to set another breakpoint for the point where we're just about to call function 2. So what we're going to do is I'm going to set a breakpoint for GDB tutorial.c, line 12. So in that case, I use the file name and line number as the mechanism to set the breakpoint. I'm now going to run the program again. Oh, I'm going to actually disable the text interface. And I'm going to run the program again. So there I stopped at the first breakpoint. I'm going to continue. We're going to execute function 1. And I'm right before we execute function 2. So we now have 2 breakpoints set. We obviously have the one starting at main, and we have a second one set. We can find the breakpoints that exist by doing info break, and I just use tab completion. It shows the 2 breakpoints that we have. I'm going to delete the first breakpoint, just using delete 1. And now if I look at info break again, I have just 1 breakpoint. So if we run again, now we stop at the second breakpoint, which is our call to function 2. We could also set a breakpoint in function 1. That breakpoint will trigger when we enter function 1. So that'd be just like the breakpoint we set for main. So I could say break function 1. And if I run again, I'll stop at the beginning of function 1. So if you don't specify a file name and line number, and you just specify a function name, you'll set a breakpoint at the beginning of that function. Once we've stopped inside of a function, we might want to see the call chain. In other words, how did we get to this particular point of the program? If we type where, we see that function 1, that's the function we're currently in, was called from function main in this file at that line number. These commands that we've gone through, which are next, step, continue, and finish, are the most common commands for moving around in a program. Typically, the method that you use to navigate through a program is to set a breakpoint at a beginning of a function that's causing a problem, and then single stepping to that breakpoint. Or if there's a lot of code that you're trying to execute, typically you would set a breakpoint at a specific function and then maybe set another one in a line number in that function, so then you can continue to that. You can also set breakpoints for common functions. So for example, if this program was to finish correctly, but I don't want it to to end and be done, I might want to set a breakpoint for the exit routine, which is executed prior to normal finish or exiting of the program. The other common mechanism, if we have an error such as this one, is to just run until we get the error and then see where we are, how did we get here, and then begin to use information in the debugger to diagnose why we're at this point. In the next tutorial, we're going to examine how to be able to use the print command to be able to print out information about variables in our program.